Earth has come terrifyingly close to wiping out life on its own surface, not once, not twice, but 5 different times. Let's start with the first attempt and find out who somehow managed to survive the end of the world. Number 5. The Ordovician Silurian Extinction. Travel back 444 million years. There's no grass, no trees, no animals on land. Nothing at all. If you stepped outside, the landscape would look like a parking lot that somebody forgot to build. The oceans, however, were overflowing with life. Most species lived in warm, shallow seas along the continental shelves. Trilobites crawled across the seafloor alongside brachiopods, bryozoans, sea lilies, and early cephalopods. Some of those names sound like paleontologists were testing whether narrators actually enjoy their jobs. Everything was going perfectly until the planet decided to hit the reset button for the first time.
The supercontinent Gondwana drifted over the South Pole. The climate cooled. Snow stopped melting completely, and year after year it piled up into massive ice sheets. As more water became trapped in ice, sea level may have fallen by nearly 100 meters, about 330 feet. To us, a retreating shoreline sounds like more beach to enjoy. To Ordovician life, it meant eviction on a planetary scale. Most marine species depended on those shallow coastal shelves. When the water disappeared, entire ecosystems vanished with it. The Ice Age lasted somewhere between 200,000 and 400,000 years, so this wasn't one bad Tuesday. Entire generations were born into a world that kept getting colder, drier, and smaller. Eventually, the toughest survivors adapted. They found new habitats, endured the cold, and slowly began to recover. It looked like the worst was finally over. Then, the climate reversed. The glaciers melted. Sea levels rose rapidly. Warmer water held less oxygen.
And just like that, a second disaster struck. First, the cold erased their homes. Then, warming and oxygen loss finished off many of the survivors. That's what makes the Ordovician extinction so unusual. It wasn't a single catastrophe. It was a double trap. The planet froze the oceans first, then completely changed the rules for everything that managed to survive the freeze. Around 85% of all marine species disappeared. It became the second largest mass extinction in Earth's history. But that raises the biggest question of this entire video. If almost everything died, who was left? A handful of cephalopod lineages and other marine survivors made it through and continued evolving. Their descendants would live long enough to watch Earth try this all over again. And the next attempt would be even stranger. This time, one of life's greatest killers would be trees.
Number 4. The Late Devonian Extinction. After the first catastrophe, life slowly recovered. The oceans filled once again with fish, corals, and countless invertebrates. But on land, something happened that looked like one of nature's greatest victories. The first true forests appeared. What could possibly be dangerous about trees? They produce oxygen, create shade, and usually play the role of the good guys in every environmental story. But this is where Earth takes one of the strangest turns in its entire history. The first large trees spread rapidly across the continents. Their roots broke apart solid rock, releasing huge amounts of minerals into the soil. Rain washed those nutrients into rivers, and eventually into the oceans. Marine life had just received a gift that was a little too generous. Algae exploded across the seas, multiplying so quickly that vast stretches of ocean became covered with enormous blooms. But every party eventually ends. When billions of those algae died, bacteria began breaking them down. That process consumed enormous amounts of dissolved oxygen. The more dead algae there were, the less oxygen remained for everything else. Imagine living in a city where someone suddenly decided to switch off the air. That's essentially what happened to Earth's ancient oceans. Today, scientists call this anoxia, a condition where seawater loses almost all of its oxygen. For most marine animals, it meant a slow death with nowhere to escape. And that wasn't the only problem. As forests expanded, they also pulled massive amounts of carbon dioxide out of the atmosphere. The planet began cooling once again. It's a bizarre twist. Plants became so successful at transforming Earth that they accidentally helped trigger one of the largest ecological disasters in its history. The extinction didn't happen overnight. It unfolded over hundreds of thousands, possibly even millions of years, arriving in multiple waves. Some species disappeared almost immediately. Others held on much longer. The outcome, however, was the same. Roughly 75% of all species vanished. Even so, a few groups survived. Those quiet survivors once again became the foundation for a new world. By now, a pattern was starting to emerge, and in the next catastrophe, that pattern would become more important than ever. Because what came next was so devastating that scientists still refer to it with a remarkably simple name: the Great Dying. Number 3. The Permian-Triassic Extinction. About 252 million years ago, nearly all of Earth's land was fused into a single supercontinent known as Pangaea. On a map, it looked wonderfully convenient: one enormous continent, one global ocean, and absolutely no arguments about where to spend your vacation. Reality was far less comfortable. The heart of Pangaea lay hundreds of miles from the sea, making its interior dry, brutally hot, and wildly unpredictable. Life flourished anyway. Synapsids, the distant relatives of mammals, roamed the land. Coral reefs thrived beneath the waves. And insects had already figured out that nobody invited them. But by now, nobody was getting rid of them either. Then something beneath present-day Siberia broke loose. This wasn't a single volcano with a picturesque cone and a smoking crater. The Earth's crust split open across enormous fractures, pouring out lava again and again. The eruptions continued for hundreds of thousands of years, burying an area the size of a large continent beneath layers of basalt. Today, we call this region the Siberian Traps. The lava alone would have been catastrophic. But the magma also pushed through coal beds and organic-rich rock, heating them until they released staggering amounts of carbon dioxide and methane into the atmosphere. Global temperatures began to climb. And not by the single degree that sends modern people arguing over the thermostat. Some estimates suggest Earth warmed by roughly 8 to 10 degrees Celsius, about 14 to 18 degrees Fahrenheit. The oceans warmed as well, and warm water holds less oxygen. Marine animals began suffocating, coral reefs collapsed, food chains unraveled. In oxygen-starved seas, bacteria that produced hydrogen sulfide spread rapidly. In other words, parts of the ocean may have become a hot, poisonous soup that smelled like rotten eggs. Evolution had finally cooked a meal nobody ordered. Conditions on land weren't any better. Drought wiped out plants. Forests disappeared. Soil washed into rivers. Herbivores lost their food. Predators lost the herbivores. And the entire ecosystem quickly turned into a very long line leading toward extinction. The catastrophe may have lasted tens of thousands of years. To any individual animal, the changes would have seemed painfully slow. To the planet, it was almost instantaneous. Around 96% of marine species disappeared. About 70% of land vertebrates vanished with them. This remains the largest known mass extinction in Earth's history. Its scale was so overwhelming that it earned its own name, the Great Dying. In some ecosystems, only a handful of large animals survived. One of the biggest winners was Lystrosaurus, a stocky, beaked herbivore that looked like someone who accidentally survived the apocalypse and suddenly realized all the real estate was now available. It wasn't the fastest. It wasn't the strongest. It certainly wasn't the smartest. What probably saved it was something much simpler. It could survive harsh conditions. It could eat tough vegetation. And it refused to quit.
After the extinction, Lystrosaurus became so common that in some regions it makes up the majority of all known land vertebrate fossils. But even that victory didn't last forever. Earth needed millions of years to rebuild complex ecosystems. And just as life finally recovered, Pangaea itself began to crack apart. Those fractures would open the door to the next catastrophe. The one that would unexpectedly hand the planet over to the dinosaurs. Number 2. The Triassic-Jurassic extinction. We've finally reached the age when dinosaurs first step onto the stage. Not as rulers of the planet, more like the weird new kids nobody takes seriously. After the Great Dying, the Triassic period began. Life was recovering, but Earth was still a rough place to live. Pangaea remained a single supercontinent surrounded by the vast Panthalassa Ocean. Its interior lay so far from the sea that enormous deserts stretched across much of the landscape. For the most part, the planet looked like an oven where someone forgot to set the timer. The friendlier environments were found along rivers, coastlines, and humid valleys. Forests returned, ferns and conifers spread. Animals slowly filled the empty ecological niches left behind by the previous extinction. One of the most common survivors was still Lystrosaurus, a pig-sized herbivore that had already outlived the worst catastrophe in Earth's history. At this point, it looked like the employee who accidentally became the only person left in the office and got promoted by default. But its reign wouldn't last. New predators appeared. Among them was Postosuchus, a giant crocodile-like reptile that walked on upright legs and possessed jaws capable of ruining almost anyone's day. Running alongside it were some of the earliest dinosaurs, including Coelophysis, a slender, fast-moving predator about 3 meters or 10 feet long. Quick, numerous, and, judging by its appearance, probably the type that stole everyone else's lunch. The first true mammals had arrived as well. They were tiny, mostly nocturnal, and did everything possible to avoid attention. A surprisingly smart strategy when two-legged crocodiles are wandering around the neighborhood. The oceans had recovered too. Ichthyosaurs cruised through the water, looking remarkably like dolphins, despite having no close relationship to them. Nothosaurs and countless other marine reptiles shared those seas. Life had become diverse once again. The Triassic lasted for more than 50 million years. Then, Pangaea began to break apart. Enormous rifts opened between what would eventually become North America, Africa, and Europe. Lava poured out across the cracks. Today, geologists call these eruptions the Central Atlantic Magmatic Province. And this wasn't a brief volcanic episode. The eruptions continued in waves for hundreds of thousands of years, pumping enormous amounts of carbon dioxide into the atmosphere. The climate became wildly unstable. At first, volcanic particles may have triggered short periods of cooling. Later, the accumulating greenhouse gases pushed temperatures sharply upward. Life bounced between cold and heat, as if the planet's thermostat had been handed to someone with absolutely no idea how it worked. The oceans warmed. They became more acidic. In many places, oxygen disappeared once again. Plants changed. Food webs collapsed. Large, highly specialized animals simply couldn't adapt fast enough. Around 75% of all species disappeared. The hardest hit were many of the dominant competitors that had kept early dinosaurs in check: large crocodile-like predators, giant amphibians, and several other successful reptile groups. The dinosaurs survived. Their efficient lungs, upright posture, and ability to cope with hot, dry conditions may have given them an edge. But don't imagine they won through some glorious evolutionary showdown. It was more like every major competitor suddenly walked out of the tournament. The dinosaurs inherited a planet full of empty ecological niches. Over the next millions of years, those once overlooked animals evolved into the largest predators and herbivores the land had ever seen. Their reign would last for roughly 135 million years. It seemed as though nothing could stop them now. But out in space, something was already heading toward Earth. Something that couldn't care less who happened to be sitting at the top of the food chain. Number 1. The Cretaceous-Paleogene extinction. After the Triassic catastrophe, dinosaurs finally got the opportunity they'd never had before, and they took full advantage of it. Small predators evolved into giants. Titanosaurs weighing dozens of tons crossed the plains. Tyrannosaurs shook the forests. The skies belonged to giant pterosaurs flying alongside the first true birds. The seas were ruled by mosasaurs and plesiosaurs. Scientists estimate that around 10,000 dinosaur species may have existed over the course of their history. If you had visited Earth back then, you probably wouldn't have noticed the mammals at all. They were small, mostly active at night, and they did everything they could to stay out of sight. Compared with the dinosaurs, they looked like background extras who had somehow wandered onto the wrong movie set. Almost nobody would have bet on them. Then came the day that changed everything. Around 66 million years ago, an asteroid roughly 10 to 12 kilometers, or 6 to 7.5 miles, across approached Earth. It slammed into what is now Mexico's Yucatan Peninsula at a speed of about 20 kilometers per second. The impact released energy comparable to several billion atomic bombs, like the one dropped on Hiroshima. First came the impact, then the shockwave, then earthquakes, then enormous tsunamis. Across much of the planet, superheated debris blasted into the atmosphere began falling back to Earth, igniting massive wildfires. But contrary to the popular myth, fire wasn't the main killer. The worst came afterward. Dust, soot, and aerosols blocked the sunlight. Temperatures plunged. Photosynthesis nearly stopped. Plants began to die. Then the herbivores disappeared. Then the predators. The entire food chain collapsed from the bottom up. It was the years of impact winter, not the initial flash of the collision, that finished off most ecosystems. All non-avian dinosaurs disappeared. So did the pterosaurs, mosasaurs, ammonites, and countless other animals. But once again, the same question returns. How did anything survive? The answer was surprisingly simple. The best odds belonged to small animals that didn't need much food. Species that could live in burrows, feed on insects, scavenge carcasses, eat fungi, seeds, or almost anything else they could find, were far more likely to survive than large, highly specialized predators. Our distant ancestors fit that description almost perfectly. They weren't stronger than Tyrannosaurus. They weren't faster than Velociraptor. They weren't smarter than every other animal. They were simply small enough, unnoticed enough, and adaptable enough to wait until the giants were gone. Sometimes evolution doesn't reward the strongest. It rewards the one that's simply too boring for the apocalypse to notice.
Because those tiny survivors made it through, tens of millions of years later, primates appeared. Then humans. And eventually, for some reason, one primate decided to make a video about the 5 times Earth nearly wiped itself out. So, those were the 5 greatest mass extinctions in Earth's history. Each one unfolded in a completely different way. First, an ice age destroyed the warm, shallow seas. Then, trees accidentally reshaped the atmosphere and helped suffocate the oceans. After that, volcanoes turned Earth into a version of hell during the Great Dying. Millions of years later, another volcanic crisis cleared the path for the dinosaurs. And finally, a single asteroid brought their reign to an end. But one pattern connects every one of these events. Not one of them managed to wipe out life completely. Every time, a small group of seemingly insignificant survivors remained. After the Ordovician extinction, a handful of marine organisms made it through. After the Devonian extinction, several resilient groups of fish and invertebrates survived. After the Great Dying, strange creatures like Lystrosaurus helped rebuild the world. After the Triassic catastrophe, dinosaurs were suddenly given their chance. And after the asteroid impact, the future belonged to small mammals. The history of life isn't the story of the strongest, it's the story of the most adaptable. Evolution keeps demonstrating the same rule again and again. When the world changes rapidly, size, strength, and status stop being the greatest advantages. What matters is the ability to adapt faster than everything else. And that's why the planet today isn't ruled by tyrannosaurs or giant marine reptiles. It's ruled by primates who build cities, launch satellites, argue on the internet, and spend their time trying to understand why Earth's previous rulers disappeared. And that brings us to a rather uncomfortable thought. Over the past several centuries, species have been disappearing tens, and according to some estimates, hundreds of times faster than the natural background rate. That's why many biologists now discuss the possibility that a 6th mass extinction may already be beginning. The difference is that, for the first time, the cause may not be an asteroid, not a supervolcano, not an ice age, but a single species. Us. Scientists continue to debate whether what is happening can officially be called a 6th mass extinction. But there is broad concern about the current rate of biodiversity loss, which makes the whole story deeply ironic. After 5 global catastrophes, life always found a way to begin again. So the main question is no longer, can life survive another mass extinction? The real question is, can we?